Hi everyone, my name is Bhavishya. In the previous lecture, we saw the properties of RIP and also the concept of load balancing in RIP. I noticed in the previous lecture at the end when I was explaining some concepts, the video got off. So here I am recording it once more. So what we were learning is split horizon. So there is a rule in RIP that the thing that you learn from your neighbor, you don't advertise it back to the same neighbor. By this, if you can see in this topology, as R1 is advertising R2 about 10 network, right? So R2 will never advertise R1 about this network, 10 network, right? So this is the concept called split horizon, that we are splitting the horizon, right? So this is one concept. The second concept is split horizon with Poisson reverse. So in this case, what happens is here we say that R2 will advertise R1 about 10 network. Sounds strange, right? But yes. But here the difference is R2 will advertise R1 about 10 network, but with the hop count of 16. When we say hop count of 16, that is unreachable. So R2 is telling R1 that via me, via R2, 10 network is unreachable. So basically, R2 is poisoning the R1's mind that via me, R10 network is unreachable. So via this, we are breaking the loops between directly connected neighbors, right? So this is one way of breaking the directly connected neighbors. The other one was the hop count 16. Here we were there we were able to break the loops, right? There are three loops. There is also one way. For that, let me pause it here to save the time. Now here in this condition, as you can see, the very first rule that we learned was split horizon, right? It says you don't advertise the same information that you have learned from the same neighbor, right? So R1 will advertise about 10 network to R2, but R2 will never advertise about 10 network to R1. But in this case, it can advertise it to R3. So R1 advertise about 10 network to R2 with hop count of 1. It install it with 1 on its own system. Then it advertise it to R3 with hop count of 2. Then R3 advertise the same information to R1, and then so on. R1 advertise R2 about 10 network with 4 hop count, 5, 6, 7, 8 till 16. And then the indirect loops, this is an indirect loop, will get break because we are counting till infinity. In the language of RIP, that when we say counting till infinity means counting till 16, counting to 16, right? So in this example, we are breaking the indirect loops. In the previous one with Poisson reverse, split horizon with Poisson reverse, there we were breaking the intermediate loops, or we can say, sorry, immediate loops, immediate neighbors. They were breaking the immediate neighbors loop, right? So this was the property of RIP version 1 and also 2, the, both of them. Other rule, that is update time. So R1 is going to advertise 10 networks information to R2 in every 30 seconds. So the pattern is, let me write it down. First for 30 seconds, then after 60 seconds, then after 90 seconds, 120 seconds, then 150, then 180. This is important, let me mark it. After that, 210, and at last 240. This is also important. Now Let's suppose R1 was advertising about 10 network to R2, and R2 was receiving and it was advertising further. Now it has missed one update. In 30 seconds we got no entry from R1 to our R2. No problem. In 60 seconds the second entry, we missed the second entry until 180. So this is the time, 180 seconds is the time that we wait for. After that, we call it invalid, right? And this is known as invalid timer. When it goes to 180 seconds, this is we call it invalid. But the entry of that 10 network on R2's routing table will be there till 180, right? And after when we have reached till 8 entries, 10 update missed. Here we missed 6 updates. Here we missed 8 updates. So this particular time, 240 seconds, are known as flush time. After 240 seconds, we are going to delete slash purge the entry of this in our routing table. So update time is 30 seconds. We wait for 6 updates. If we miss it, we call it invalid. We mark it as invalid. We down we down the network. After that, in 240 seconds, after we have missed 8 updates, we delete the entry. So this was the concept of our update time, invalid timer and flush time, right?